Alright, so good morning. This is our project 2 for robotic design. I'm Marybel Hernandez, this is Rodrigo Arredondo, and Michael Wolff. And we started off this project thinking that it was going to be pretty easy. Programming, we all had a little bit of programming, but when we got up there with the robots, wow. The first task is a dance routine. This will be about 1 minute. We chose to do the electric slide, or the song is actually called the Electric Boogie. We used a series of subroutines. Basically, we started off, routine 0 is basically just to get on task with the music to catch up. It has about a 2-minute pause, and then it goes forward, and that's it. The electric side, for people who don't know, it's 4 counts to the right, 4 counts to the left, 4 counts back, and then you lean forward, you lean back, and then you turn to do it again, facing a different direction. So routine 1 is basically the going to the right. It turns, goes forward, goes back, so it returns to its initial position. And then routine 2 is moves to the left and then moves back. And then it goes back. On the back, we wanted actually to sort of count the steps, so it did like a snake movement, a waggle. And we used a spiral, which is basically if one wheel is moving faster than the other, so it did this kind of snake-like movement. And then routine 5 is just where it turns, and then it goes back to routine 1, and it does the electric slide again. And the video. Wagon. Funny thing about the robots, sometimes they would get off different angles, and somehow when they turned again, they were in line. Alright, and now I'm going to pass it on to task 2.
For task 2, it was an environmental scan, and the objective of it was to find the farthest away object and return to that position and move within 2 inches without touching it. Some basic things we had to set up was, the thresholds of the wall and the maximum distance that we wanted to be searching. And we did that via doing a debug, and we found the wall distance to be about 10 feet. And then our farthest distance threshold, we started at around 4 foot to be the maximum distance. So what it does is it is a 360-degree scan, stores the values of the position and the distance at that particular position. And then if the next distance is farther, it will store that new value. Now, once it completes the scan, it then will return to the position by reverse rotation as opposed to continuing on the 360. And we found from one Bobot to the next, that was the most efficient way of doing it because of the calibrations. And it always reached that position when we did it like that, returning as opposed to keep on going all the way around. And so it goes. So this is our flow chart. Basically what I explained there. This is the reverse position after it has gone through the distance check. And then once it returns to the position, it goes forward to 2 inches. When the distance is 2 inches, it will stop and then repeat the whole process. So here's the video of this operation. As some of the other groups did, we put a pause in, so as soon as it gets a new maximum distance, it pauses for half a second. there's something wrong with it's like missing frames or something. I mean, you can't really see the whole operation. But that was the last stored maximum distance. And also we programmed a small little step at the end where it moves away from the wall, so when it does the turn, it doesn't bump any of the sensors, or it's just a smooth operation. The pause, and it should get just right over here. All right, here's Rodrigo with task 3.
So for task 3, this is a rough version of what is eventually going to become our final project. For our final project, we want to have an electric lawnmower that scans an area, finds grass and cuts it. These are some other different purposes: paint driveway, clear snow, and so on. The way we are going to be detecting grass is using the light sensors. Whenever grass is in contact with the sensor, it's going to block light from it. Therefore, it's going to be finding grass. And it's going to start a routine which is going to cut an area, increasing radius. It's going to be moving in circles with increasing radius to cover the most area in 1 by 1 foot. So this is our flow chart. These are the light sensors, these are the ultrasounds, and these are the whiskers. The ultrasounds and the whiskers are going to be used to detect objects, whether they are moving or they're stationary. For the moving ones, it's going to be mainly the whiskers. Whenever you touch something that is moving, it's going to move away. Here we have, for the ultrasound, 2 conditions. One of them is if there's a close object, it's going to make a hard turn to left or right, depending where the object is. And for an object that is in a further distance, it's going to do a slight turn, making sure it's still covering the most area of grass. Now, if the light sensor detects there's no light, it's going to go ahead and do the routine that is going to cut grass, and it's going to do the object detection at the same time. And if it doesn't detect anything, it's just going to keep going until it finds a spot where there's grass. And let's put the video. So this first part right now is going to be the object detection. So you guys notice that flash? We turn the lights off, simulating that it found grass, and this is the cutting routine. So you can see it's increasing the radius of the circle that it's going through. So right now it's looking for a new place to cut. Right? Yeah.
So as it's doing the cut there, it picked up the object and it moved accordingly.
You see, it avoided the object and it kept cutting the area. And there is doing the routine again. Right? last, we have some recommendations. For instance, buy your own bullet, so we avoid working with a damaged one. Maintain your batteries charged, since different voltages affect the performance. Also, in the code itself, implement variables, so it's easier to calibrate, and as well add pauses for operation verification. And finally, avoid too much contact with the sensors because it can damage it, and I'm sure no one wants to pay them. So that's it.